Today we're going to be doing combining like terms and distributive property. This should be on page 10 of your notebook, just after those properties notes, just after the property notes. If I have the page number wrong, let me know in the comments, but it should be after the properties notes. As we are going through today, we're going to need to know what a term is first. So our vocab word here is term. I'm going to make sure that is underlined because that is a vocab word. All right, a term can be numbers. It can be variables. It can even be operations. Separated by addition and subtraction. Now, I'm saying subtraction. Technically, it's only separated by addition. But I want you to know subtraction because some of us still have trouble seeing that subtraction sign as a negative. So let's look at what would a term be. Oh, great question. So let's say I'm going to draw this out here just because it's easier to draw some of those math symbols than type it. So let's say we have 5y cubed plus 2y squared minus 3z plus 7. Now, if we look at this, I can ask you, how many terms does this expression have? There are 4 terms. So we're looking at it separated by a plus sign. So if we look, this 5y cubed is a term. It's separated by a plus sign. We can have multiplication in there. We can have exponents in there. That's fine. But the key is that it's separated by that addition sign. This positive 2y squared is also a term right here. Here's where it gets tricky. I put the subtraction, but technically it's not 3z. That is a negative 3z. And so I'm going to be like, whoa, hold on. What? That term is a negative 3z. Now here's why. If we look closely, it's kind of like we have a 2y squared plus a negative 3z. If they're right next to each other with subtraction, it's like we're adding a negative. Subtraction is adding a negative. It's like adding the opposite. So that's why we see that as a separate term. So I want you to be careful with that with the word subtraction. The negative does still go with the term to the right. So going back to terms here, we have our positive 2y squared. We can even make sure the positive stays with it if you want. I mean, it's up to you. Technically, if we circle this, this is also still a positive 2y squared. Negative 3z and a positive 7, which is our constant term. It is constant because it doesn't have a variable. All right, good. We have our terms. So our goal is to combine like terms. Well, what are like terms? Great question. Let's add another vocabulary word. Like terms are terms with the exact same variables. I don't want to put including. We'll just talk about what that means. Vocab word, that's important. So like terms, they have to have the exact same variables. So I'm going to be listing out a few like terms here for our examples. That could be like, nope, I need the drawing tool. That could be like, let's go with 3/4 x and 7 2/10 x. They have the same variable. They both have an x. Those are like terms. Now be careful. Here's something that is not a like term to that. x cubed. See how that one's just one x? That's three x's. Be careful. Yes, they both have x's, but these are not like terms to each other. Because this is x cubed, there's three of those x's. So they need the exact same variables, including the exponent has to be exactly the same. So 5x cubed can be a like term to... Let's throw in another fraction here. 1/2 x cubed. Oh, look, those are like terms. So be careful with the exponents. Make sure the exponents are also the same. So let's do some examples here. I'm going to be writing out these examples just because the exponents are easier to draw on here. You with your pencil in the notebook, easy. So let's do an example. Let's go with 3x plus 5y minus 7x plus 7y squared minus 3. Plus x minus 4y plus 7. There's a lot of 7s in there. Anyway. Those are a lot of terms. Our goal is to combine the terms that are like terms. Now you are welcome to use highlighters. That's nice to highlight different terms, but I know not everyone has different color highlighters. Most of us just have a pencil and one color highlighter. So if we use a pencil, we can do this with shapes. So we can circle, box, triangle, trapezoid, each of the terms that are like terms. So if we start here, I'm going to push for technique, which we've been talking about. We want an alphabetical order. When we start to have exponents, we want the highest ranking exponent first. That's key. So if we look at all of our exponents, those are all 1 to the power of 1 to the power of 1. Here is the highest ranking exponent right there. That's going to go first. So we have 7y squared. So exponents outrank alphabetical. Then we can go to alphabetical order. That's how it goes. Okay, next. So we have our 7y squared first. Next alphabetical, we either have x's or y's. X's or y's. Well, x's go first, so I'm going to box those. I used a circle first time, so I'm going to box the x's. I'm going to be putting a 3x. Now be careful with your boxing. That is a negative 7x. You need to be able to see that negative. That negative has to go with it. It has to. It has to. So we have a negative 7x. And we got this positive x just floating out here. And if it helps you, box that sign out front every time. Every time. Then you'll make sure that your signs are in the right spots. So if we have these being put together, we have 3x minus 7x plus x. Keep in mind, this is adding an x. I didn't say how many x's there were, but it's that secret implied 1. How does that work? Well, it's like if I say I have a coffee here. I didn't tell you how many coffees I had. I said I have a coffee. But you know that it's singular. So it's that implied singular wording that we use. So this is, we're adding an x, we're adding 1x. If it helps you, put the 1. If it doesn't help you, don't put the 1. If you have questions about this, ask them in class. Next class, we'll discuss. Okay, so we have 3 minus 7, which would give us a negative 4, plus 1, which would give us a negative 3x. We just put all of those 3 together right here into one term. We combined our like terms. All right, it's going to get a little drawing weirdness here because we're going to start drawing triangles. And I always try to draw them a little bit taller than normal, or else mine start to look a little funky with trying to get everything in there. So if we're going for our next variable, that would be our y's. So we have a positive 5y here. Ooh, there we go. That was a pretty decent one. That's a good triangle. And we have a negative 4y. Make sure that negative makes it into the shape. Now, can you pick any shape? Sure, if you wanted to do a star, that's fine. I just picked circles, rectangles, and triangles because they were pretty easy. Okay, here we go. So we have 5y minus 4y, which would give us a positive 1y. Now, the highest level of technique, like you saw with this x here, is we don't write plus 1y. We just write 1y. Look, I drew 1y right there. Just one of them. I just drew it. So you don't need the 1 out front. You could put it, but we don't need to. And the highest level of technique is not writing it. All right, then from here, you can just do the not circled ones, boxed ones, triangular ones. Or you can pick a new shape. Maybe I'll do a cloud. -3 and +7 are also like terms. And some of you are like, well, don't they have to have the same exact variable and they don't have variables? Well, that's what they have in common. They don't have variables. And it's like we've been doing this our whole lives. We've combined like constant terms all through elementary school. We've done, well, maybe not -3 + 7. We've done that since last year, though. So -3 + 7 would give us a +4. Ta-da! So that is combining like terms. Let's see if I can get a new page here. Okay, I'm going to clear the page and then we will do the distributive property because I'm kind of running out of room. This isn't quite enough room that I want to use. If you've also run out of room, you could go to the next page, but I think you should be good if you're only like halfway through the page for distributive property. All right, here we go. So distributive property. We did this last class and some of you are like, I know how to do this. Okay, but there's a few pieces I want to point out because now we have combining like terms and distributive property and we're going to kind of mix them together a little bit. But before we do that, let's do a simple one just to make sure we remember. Let's do a nice simple one. We're just going to start off with examples because we already have our definition and on the last page here. So just one example to just kind of get us going here. 2 times 3m minus 4. Keeping it simple, right? Keeping it simple. All right, so our 2 is what is distributed to each term within the parentheses. Our 2 terms here. This is a binomial because there are 2 terms. Okay, but that's not a vocab word we need to know right now. All right, so we have our 3m and our -4. So 2 times 3m would be 6m. And 2 times -4 would be -8. That's as far as we can go because if we look, 6m and -8, they're not like terms. So we're done. Now, I'm going to kick it up a notch, just a smidge here for some of us. I'm going to do an example over here just to save some space over here to the right. We're going to do one just as simple, but it's going to look backwards. If I open a set of parentheses and do 5y minus 3 all multiplied by 4. We can still use distributive property. This is technically distributive property and commutative property of multiplication because we can do multiplication in any order. So that 4 is still getting multiplied by everything in the parentheses. It's just coming on from this side. See, I said we were doing it backwards, almost literally backwards. So 4 times 5 would give us 20y. And 4 times -3 would be -12. And we've simplified. The end. Okay, now I told you it was going to get more complicated. Yes, here we go. So this example is going to get a little tricky. So let's say we have, I'm feeling the 3s. Apparently I got 3s and everything. So we're going to go 3x minus, open a parenthesis, 5x minus 3 plus 2x. Close it. Now some of you are like, okay, I see the parentheses, but I don't see anything to distribute in. And then some of you might be like, oh, the 3x, we got to do the 3x to distribute in. Well, no, see how there's that minus sign there? That is 3x. And we are going to subtract everything in those parentheses from that 3x. Everything in the parentheses. We're going to subtract 5x. We're going to subtract a negative 3. And we are going to subtract a positive 2x. We are distributing. We have to distribute the negative, which is weird. Some of you are like, well, negative's not a number. Well, no, true. But remember we talked about that secret 1? And when we just have a set of parentheses, we have negative 1 sets of those parentheses. Told you, it gets a little weird. I'm ready for all your questions next class. Don't you worry. Write down your questions. If you're going to think you forget, just write them down. So negative 1 is going to be multiplied by everything in these parentheses. It's the same thing as subtracting the 5x, subtracting the negative 3, and subtracting the 2x. Some of you are like, wait a minute, multiplying and subtracting, same thing? Not quite, but it's let's just do it and look. I'll show you. So let's do the subtraction idea first, and we'll go with that. So our 3x just kind of hangs out up here. Nothing happens yet. If we're going to subtract 5x, we would write it as minus 5x. If we're going to subtract a negative 3, that's the same as saying subtract a negative 3. Some of you are like, Miss Icework, can't I just put the positive? Yeah, you could. I'm writing it out, though, to show you the minus the negative 3. Okay, then we minus this positive 2x. If we're going to subtract that 2x, there we go. From here, we can then use our combining like terms after we've used our distributive property. Okay, now I told you about the multiplication. Are you ready? Here's how the multiplication looks exactly the same as distributing the subtraction sign. Negative times a negative 1 times positive 5x is a negative 5x. A negative 1 times a negative 3 will become a positive 3. And a negative 1 times a positive 2x is a negative 2x. So it's kind of how you want to visualize it. If you want to visualize it as subtracting every term in there, or distributing the negative and multiplying, your choice how you want to visualize it. From here, we can combine our like terms. Well, we need our variable first. Oh man, we have a lot of variables here that are like terms. We got a 3x, we got a negative 5x, and we got a negative 2x. So we have our 3x minus 5x will give us a negative 2x and a negative 2. And negative 2x makes a negative 4x. Then our constant plus 3 here has no other like terms. So we just bring it down. Plus 3. Is it weird? A little. So bring these notes next class. See, there's probably enough room. I might have been able to fit it at the bottom of the other one. But bring these next class with your questions, and we're going to be practicing these things in class.